department at Sri Vasavi Institute of Engineering and Technology, Nandamoru. Today I am going to discuss a topic in digital signal processing, that is about even and the odd signals. First we discuss what is meant by a signal. So how do we define a signal? Anything that carries an information is said to be called as a signal. So in general we can say a speech signal can be an example for a signal. So how many types of signals are being classified here? There are three types of signals: continuous signals, discrete signals and the digital signals. Let us see the first two signals here. What are the continuous signals and the discrete signals? So first one is called as a continuous signal. The signal which is continuous with respect to both time and amplitude, we are going to call that signal as a continuous signal. So if we speak about the discrete time signal, the discrete time signal representation will be like this. How do we define the discrete time signal means? It only defines at the discrete instance of time. Here in the continuous, it defines at the continuous instance of time, but here only at the discrete instance of time. But both are continuous with respect to the amplitude. And here the representation of continuous signal is x of t, and the representation of discrete signal is like this, x of n, and here on x-axis representation in terms of n. That is the representation of both continuous and the discrete signals. Now coming to the classification of discrete time signals. So there are different types of discrete time signals. For example, deterministic and random signals, periodic and non-periodic signals, energy and power signals, causal and non-causal signals, and even in the odd signals. So today we are going to discuss about the even and odd signals. So generally any signal is a combination of both even component as well as the odd component. So here we can write like this: x of n, if you take a signal, that is the combination of both even signal and the odd signal. Xe of n represents the even component of the signal and x naught of n represents the odd component of the signal. So now let us talk about what is meant by an even signal. A signal is said to be an even signal if it satisfies the condition, this one. Any signal, if it satisfies the condition x of n equal to x of minus n, then we can say that signal is said to be an even signal. And also we can say the other name for even signal is called as a symmetric signal. Now let us see the representation of even signal. That is the representation for an even signal. So how the even signal can be written as like this. That is the expression for the even signal. Now if you talk about the odd signal, so how we define an odd signal? If it satisfies the condition x of n equal to minus x of n for all n, we can say that is the representation of an odd signal. So here we can see the graphical term, the graphical representation. So this is the graphical representation of the odd signal. And we can say the other name for odd signal is the antisymmetric. That is the representation of even as well as the odd signal. And here we can write in the terms of this one. That is the representation of the odd signal, x naught of n equal to. So let us consider a small problem here. So let us take x of n, the sequence -3, 1, 2, -4, 2. Here the arrow represents the origin. And x of -n sequence will be written like this. The origin sequence number will not be changed, but if you write the x of -n, then the terms that are numbers that are on the left hand side will be coming into the right hand side, and the terms that are in the right hand side will be coming into the left hand side. Now how to calculate the even component as well as the odd component of the signal? Now here we can see the formula is xc of n equal to x of n plus x of -n. So here we can say the first term -3 plus 2 and the second term. Similarly the third term and the fourth term. So here we can see xc of n, the representation of even component of the signal. In the same way we find out the odd component of the signal x naught of n. So -3 -2, 1 plus 4, 2 minus 2, -4 minus 1, and this is 2 plus 3. So here this is the odd component of the signal.